I'm Sue Grimmond from the Meteorology Department in University of Reading, and so I'm going to talk about issues at the urban scale. A number of people have contributed to this work. So what we're interested in is that we're actually going to build buildings that was which was just suggested by Carl. We need to be thinking about what the climate is like in the future. And the challenge is how do we actually describe the cities in our models, or how do we actually get the meteorological or climatological information that we need right now. So at the global scale, when we do global climate predictions, some of the models now have cities in them, but most of them don't. And if they do, it's taken as a very simple structure. As we come down to, say, modeling at the scale of the UK or a smaller region, then we would be starting to know something about, say, the heights of the buildings. And then when we get down to the neighbourhood scale, we may be starting to take into account the variability of the buildings, and then down to the building scale itself, where we would actually know about the details of balconies and things like that. But we have limitations in terms of the capabilities of those models, because they may, for example, only consider neutral conditions. So what I want to look at first is what is the data that we use now, and what could we be using in the future. So what's critical is what is the nature that's been taken into account in the urban form. So today in the UK and many countries around the world, what's typically used for making decisions about design from a meteorological, climatological perspective is past data. So that clearly does not see the future, and it's often extremely coarse. So, for example, in China, we're looking at the map on the right-hand side, is that you would see that there's only about 10 units that are describing the whole of China, and that only a very small, so it's very unlikely. For example, if you look at this hot summer, this is Shanghai here, this is Chengdu, Chongqing in the middle. Those are very wide, much larger than the whole of the UK, and yet we would only use one set of data for actually describing how building design should be taken into account. And it's all about past data. It's not the buildings that we're building today should be for 50 or 100 years, so we should be taking that into account. So we can, using, say, degree days, so cooling degree days, heating degree days, radiation, wind speed, improve that to come up with an improved resolution information of, instead of just having one class, sort of splitting it up by 20 classes. And we can then use something like Energy Plus to actually see that there is quite a large difference in terms of the ability to design buildings that require less energy to actually operate, and therefore saving greenhouse gas emissions by making that more discrete. But this is still incredibly coarse. If we think of, here is Shanghai, here's Chongqing, here's Chengdu, that we're not even at the scale of cities. And these cities, Shanghai is about the second largest city in the world, 30 million people. We're not taking anything into account of the spatial variability across the city. So in terms of our large-scale modeling, we can get something with respect to the city, but what if we want to actually characterize more fully the spatial variations across a city or between cities? So one of the things that we can do is characterize a city. So for example, the building materials, the reflectivity, the population density, the energy use, the nature of the heat capacities, the surface cover, how much vegetation is present, building heights, related to meteorological variables, and be able to model that. So one of the tools that we can use is UMIP, but there's a whole variety of these different models. So one of these allows us, this is an example of New York, is to actually take the regional data and downscale it appropriately for the city scale. So here we have the 5 boroughs that make up New York. So here's Manhattan. Here we can see, individual blocks. So this means that we need information like building heights, land cover, nature of the vegetation, population density, how that varies between day and night, and land use. And from that we can start to model the energy. So for example, in this building right now, there's an incredible amount of heat that's not naturally here. So the anthropogenic heat you can see, so from Manhattan, that's very large compared to the sort of more suburban boroughs. We can look at the energy that's warming the air and actually look at the air temperature itself, and then come down to the scale of the neighborhood scale. So we have some idea of what that pattern might be across that city. So instead of just taking one value for the whole of New York State, we can start to look at variability across the city. So we've gone from, instead of just looking at across one region of China, we're coming down to looking within a city and looking at spatial variability, so that we're modeling that variability and getting more realistic variables that can be used for planning. And obviously the beauty of this is once we have a tool that we know is working well currently, then we can be using the future climate projections to use it appropriately. But there are lots of things that the models, it's much better to have a model and to be taking into account the characterization, but there's still lots of things that are not as good as we would like them to be. So this is a model of sort of around the Imperial War Museum in south of the Thames, and this is the nature of this is the actual variability of the building height there, and around there is actually 3 quite tall buildings. At the moment in our models, we know nothing about those buildings at any scale, and so we need to be starting to think about, okay, how can we actually make certain also that the climate models take this into account? Because in the future, we know that it's really important, the variability of buildings in terms of ventilation. So it's good that, we've got to take the steps forward. So urban form and function are really important in terms of helping us to improve typical meteorological year data. The same tools can be used at a whole series of scales, so from the region to citywide to neighborhood scales, and then actually to be informing the boundary conditions for neighborhood scales or building scale models, so that those models will also be improved. The meteorological models are not perfect, and what's really critical is that, as we know more about how can we improve those models, then we can actually be making certain that we're working together to improve the science. Because with the demand for, we need to know more about wind information, or we need to know more about temperature information, then we can actually be improving it. So once we have this data, that's going to be useful for a whole series of researchers and practitioners. The example which I gave for New York is actually being driven by public health, so heat wave concerns in New York, but it's also, we've been working with London thinking about variations at neighborhood scale for planning. Thank you very much.